Okay, whilst we're sorting out logistics, so, we all got thrown into this a little bit last minute and are probably all very unprepared, but hopefully it will make some sense to everybody. I'd actually be interested in knowing a little bit about the audience first. Who here is more of a developer? Okay, 3 of you. All right, this is a good start. Okay, and who out of those 3, or you can be a non-developer developing in smart contracts? Who's actually developing smart contracts? Nobody. This is good actually. And who's interested in developing smart contracts? Okay, that's better. We got the right mix here then. Good. So my questions are going to be more aimed at those people. So that's good. Cool. We're all here. Great. I think I might subtitle this talk also making a white paper a reality, somewhat related. So, firstly, let's start. Actually, it came up quite a bit in the last talk, and just in case people aren't sure what it means, what is a Turing complete language? Anyone want to take that? And we'll see how we go with cables here.
I have an extra.
Oh, there's another mic. Okay.
Maybe this. Which one do you want to pass on?
What is a Turing complete language? Who'd like to take that?
Sure, yeah. So I mean, I'm not a computer scientist really, but I would say that a Turing complete language is one that you can implement any other language in, or you can implement any other language in the Turing complete one. I don't think it's a great definition, but also you can implement a Turing machine, and using a Turing machine you can implement that language. Also, there's a kind of equivalence between, in the sense that like you can always express any thing in a Turing complete language in another Turing complete language, and vice versa. I mean, that's all I got.
I think it's good definition actually. So, well, Turing complete language is such kind of language where you can implement whatever you want. So, if you have some idea, you can implement it there. Well, I think it's a bit shorter, maybe simplified definition, but you can implement whatever you want. Even if it's some nonsense program like infinite loop and so on, you should be able to implement infinite loops in Turing complete languages. It's one of its definition, yeah.
Okay. We're going to swap mics around here now. Okay. We'll keep this. You hold on to that for me. Thank you. Okay. So I guess a lot of smart contracts have their own form of standards, and maybe the most popular one or the most common is the ERC20 with the Ethereum smart contract and token standards. Firstly, are there any others, or is that the only one people need to worry about? And what does that actually entail? What does it mean? What does it define? Who would like to take that?
Okay, actually, ERC20 is related to Ethereum only, and it's a way to create a token on Ethereum, because you can't create a token on Ethereum without a smart contract. Everything you do on Ethereum is through smart contracts. So you need some type of protocol, some kind of template for token creation. That's what the ERC20 is. It's related only to Ethereum. On other smart contracts platforms, you don't have ERC20. Of course, this is the most successful one, but on the other hand, the problem here is you need this contract only for one thing, for token creation. And there are systems, for example, like Waves, BitShares, many others, where tokens are native. Like you create a token as a basic thing on your network. So you don't need a contract to create a token, because tokens are like a basic element of the network. So ERC20 is limited only to Ethereum, and that's why it's like future depends on the future of Ethereum.
And what in its case, what does it you can take the question if you like, that's fine. What does it define? What does it allow you to do? How limiting is it?
It allows you to do many things, but actually what people use it for now is creating a token and doing an ICO. So like 99% of all action on Ethereum is ICO related. So
forgot about kitties, I think. So,
that was an IKO, so I guess. And so, is there a difference between a smart contract and a token, or are they connected to each other so closely that there's no real difference?
For sure, there is a big difference. I can try to answer. So Alex told about smart contracts with Sigma language. I don't remember about tokens there, but it's smart contracts may be useful for different stuff. I already mentioned CryptoKitties, quite interesting example of smart contracts usage when people spend millions of dollars to give a need to its pet, virtual pet. But actually, no, as Sasha mentioned, there are different languages. In Ethereum, as far as I know, ERC20 is like outdated standard. Maybe Vlad knows better. There is a new standard for token creation right now. It's possible to create tokens in Bitcoin, for example, with Bitcoin scripts. There are examples of such tokens. But it's not just about tokens. It's about everything you want. It's about building off-chain protocols on top of blockchain. I'm waiting for Lightning Network. It's quite interesting example. It's about privacy also, about this mixing ideas or ring signatures. Who knows how will people use it in a few years? Nobody knows. I think CryptoKitties example is quite new. I don't think that a lot of people thought about it like half a year ago.
Whenever there's the internet, there is cats. I'm sure someone thought of it a long time ago. So I don't know if we should stick with Ethereum just because it's one that more people know or not, but it's up to you in your answers and your experience. But let's start with smart contracts. How does someone write a smart contract? Where do you write it? What's the kind of style of the programming language or the scripting language that you use? How does someone actually write a smart contract? If anyone else.
Okay, I'll try to answer.
Sure.
I'm not actually a big expert in writing smart contracts on Ethereum, but as far as I know, it has quite rich environments. So there are web script interpreters. You should use one of supported languages, but the most known is Solidity. So you should learn this language. It's similar to JavaScript, I think, and quite easy. You could go to any website and write some code there, check whether it works. There is test environment. I don't remember all the names, unfortunately, of these projects, but you can test your smart contract on virtual blockchain. You create your own blockchain to test your contract and so on. So right now environment I think is quite rich for very young language.
Are there any others as well? Does anyone know of any other alternatives to Solidity on Ethereum as well? Anything that you're using? I mean, I know some of you are creating your own, but before that, what were you using?
I believe Solidity is number one. It was Serpent, pretty popular like 2 years ago. Now it seems to be like totally dead. And about environments, there are some IDEs, even virtual, so you can play with Solidity in your browser. The problem with Solidity, it hides semantics of the virtual machine. And actually you need to understand the semantics pretty well in order to not to lose your money in the first place. Bugs like DAO bug when $40 million were stolen, and so on. So actually this high-level JavaScript-like language, which is super easy to get into, it's hiding the semantics of the virtual machine, and then it's easy to do things in the very wrong way. And actually, now in the end of 2017, we are just starting to understand, the dangerous things about the semantics of this virtual machine and how the semantics is interacting with Solidity layer and so on. So for now, there are some recipes how to write a safe smart contract, as we know now. What does this mean? What does the safe smart contract mean? But we don't know about possible future problems, so it's quite developing space.
I was going to follow up this with another technical question, but you actually brought up quite an interesting kind of point that it feels like to mention more of a sort of community question, in that, lots of people say the blockchain space now is basically like the internet was in the late 90s, and I can barely remember that, and I wasn't a developer then, so I can't really remember what that felt like. But at the same time, I wonder, like for you here and anyone else, there are so many constantly new blockchain-based frameworks, languages, projects emerging, and everyone is still learning as they go. No one is really an expert. It's very new. What's it like developing these things constantly with everybody watching you? Like the Ethereum example was a classic example where a developer, I think, actually just made a mistake and all those tokens were lost. And these things can happen so easily because everyone is doing it so quickly and doing so much. And how does that feel? Looks like you want to answer.
Vlad, maybe the question for you.
Well, I'm not a developer really. I'm a researcher, and I work on the like blockchain sharding solutions and kind of proof of stake, like consensus stuff. And definitely the CryptoKitties and ICOs doing a lot of transactions puts the pressure on us to try to get the thing to scale as soon as possible. So it does kind of reprioritize things, but I'm not on the front lines. I'm not dealing with my users losing money or consensus critical bugs, days before hard forks or anything like that. From a research point of view, it's not that bad, although, it does kind of reprioritize stuff.
Okay, I'll try to add a bit. I absolutely agree with what I think. And actually now in blockchain, it's very difficult to fix your problems. If you wrote incorrect smart contract, you lost your money. You can't restore it from backup. You can't roll back. Well, we know some examples of rollback. Actually, you can, but I think it's the only example, and it will be the only example even in Ethereum. So it's not so easy question, but in blockchain you control all your money. It's the main idea that there is no trusted party, there is no some guy you can go, some organization you can ask, give me please my money, I forgot my password. If you forgot your password, you lose your money. If you write wrong smart contract, you lose your money. And the value of these contracts is very high. They should be absolutely perfect, very close to perfect, to protect millions of dollars actually, yeah. So we know a lot of examples, mostly from Ethereum, because it's mainly mass adoptive and it allows to write a simple script for everyone. How people lose their money, how the money are stolen, they are locked because of deleted contracts and so on. But actually, you can lose your money in a lot of blockchains, not just in Ethereum, but Ethereum just allows you to write a contract on a high-level language. You think it's easy to write such a contract, but it's difficult to write a secure contract in Ethereum. Maybe even it's easier to write secure contracts in Bitcoin with Bitcoin script. I'm not sure, actually. Well, this is a very difficult topic and very important. You should really write your programs close to perfect, absolutely secure.
Actually, I actually wrote this down as a question based on something you said in your talk, but anyone else can take it too. You're starting to go there yourself about making smart contracts efficient. I mean, in this kind of day and age of cloud computing, any kind of application needs to be efficient because it does cost money to run it, but a smart contract literally costs money to run it. So how, I mean, I guess this is probably a very big topic, but how do you make a smart contract efficient then? What are some of the tactics you've tried anyway?
So just throw away everything possible from the blockchain. This is the best way to have an efficient blockchain. So Ethereum is, well, not a perfect example here because you need to execute all the contracts ever entered into the blockchain if you are processing the blockchain from the Genesis block. Also, contracts are living forever. So there is this suicide command, but this is like, nice command in Linux. So this is nice, but nobody is using it. So the same with freeing space in the Ethereum blockchain. And actually, it could be a hard problem. So for example, during attacks on Ethereum in autumn 2016, so one attack done the time was about, so it was about 1 million accounts in Ethereum, so human-made accounts, human-controlled smart contracts, and the attacker figured out a way to create contracts for very cheap, almost nothing. And the attacker did create 18 million accounts, and then actually, the same attack was against Bitcoin back in 2013. So this state went from random access memory on most of machines into hard disk drive, and hard disk drive is still very slow. There is not much progress here since 80s. So it has a mechanical part which is crazy slow. And then, when this state is on hard disk drives on most of machines, so attacker is just called random accounts, and then most of network was stuck because of, some blocks did require like 2 minutes to validate on ordinary machine, and in Ethereum blocks are coming every 15 seconds, so most of network was out of sync the time. And later this problem was fixed with the help of hard fork, but now, very naturally, Ethereum got 15 million contracts, so who knows whether we will see some problems about this storage or not. So Bitcoin has the same problem back in 2013. For now, they have some more or less efficient in-memory storage. Some, pretty smart caching strategies, but who knows? And about Bitcoin block size civil war. So it actually was one argument in the developers community. So if you increase block size, then this state to be held in the random access memory, Bitcoin is not storing it's fully in random access memory, only most accessed parts of it, so some caching strategies, actually pretty smart are deployed in the reference implementation client. The problem is that with bigger block size, with bigger usage of the blockchain, so the state is going to explode potentially, and this is the huge problem. And there are other problems. Well, most of people don't realize actually.
So keeping it simple is even more important. Just actually, a question that's always intrigued me quite a lot, and actually a couple of friends of myself, and one of them is sat right there. We tried to make our own community token at some point, and we got to a certain point where we couldn't figure out what the next steps were. We created a smart contract, and then you see lots of platforms that use smart contracts at the core, but they have other technologies on top of them. And how do you actually integrate a smart contract with other programming languages, with a JavaScript front end, with a back end database, etc., etc.? How do you actually leverage a smart chain in a whole application? Are there SDKs that exist, or is it API access, or it's always been something I've been interested to know. How do you actually connect it to other things?
Actually, at this stage it's pretty hard to connect Ethereum smart contracts to anything really working, because Ethereum is a great platform for prototyping. You can do a prototype of a production system, but you can't do a production system. Because, as you know, for example, CryptoKitties, they just are killing the network. Yeah, so you have one successful application on Ethereum, and the network is dead. So I don't think it's a big problem, because Ethereum didn't promise to be the final solution. It's just the first step towards something bigger, and sharding and Casper protocol might change that. So for now, you can do prototyping, and people have to realize that what Ethereum offers is not the final solution. It's just the first step in the direction of efficient smart contracts. And what you said, that you have to pay for smart contracts, it's valid only for Ethereum, actually. For example, what Sasha proposes is another system where you don't have to pay for the execution. You pay for execution of a smart contract the same fee that you pay for a normal transaction. So it's a different approach. What Ethereum did, they said that we need to make the language Turing complete. So you can potentially, you need to somehow mitigate the chance of creating an infinite loop. So let's have people pay for the transactions for the execution of each step of the program, and this way you won't be able to execute an infinite program. Yeah, so because you won't have enough money. But it's a very simple approach, actually, and this is the first idea that comes to mind. So there's going to be other approaches, definitely, so more sophisticated. So this is the first step in the right direction, and more efficient systems are on the way.
Unfortunately, we're out of time. I had about 20 other questions I would have loved to have asked, but we're out of time. I guess just very, very, very quickly, as a thank you, in 2 seconds or 5 seconds maybe, what are the developments in the community you would like to see in the next 6 months? Just as quickly as you can, what would you like to see in the next 6 months in the blockchain space and community? And thank you very much as you give me those points.
Yeah, I want to see people working on identity systems not leak any information about their use on the blockchain, zero information.
I'm looking for, I'm waiting for some good protocols on top of blockchain. I'm interested on a Lightning Network. It's quite exciting step. I hope that it will work. I'm not sure about it. We are living in this interesting time that we don't know whether this approach will work or it won't. Raiden Network and Ethereum and so on. So I'm looking for, I'm waiting for good protocols on top of blockchain, on top of Bitcoin, Ethereum, and others transactional language.
Actually, what we need is some other application of blockchain technology, because now you have open blockchains used for value transfer, Bitcoin, and for tokenization of venture investment, ICOs. So basically you have two applications that really work. and we need some other applications. You have so many prototypes, but you need one working application. Can be voting system, can be something else. So let's see what happens next year.
So I hope we'll find more efficient privacy solutions and also better integration of off-chain and on-chain protocols and better understanding of generic interaction of these parts.
Thank you. It's a very exciting space. It's a very busy space, and thanks for everyone for joining me.